There's another theory about wormholes. Physicists proves wormhole travel is possible, but it's not what you think. Now, I want to just briefly touch on this just to show that there is not a consensus when it comes to wormhole theory. There's not really a consensus at all. This one is strange. This one is weird to me, and I don't fully get it. I don't fully understand, but we're still going to talk about it anyway, and then maybe you guys can help make sense of it. But it says a Harvard physicist has likely ruined the dreams of many a science fiction fan by claiming a real wormhole would be useless for deep space travel. Films such as Stargate and Interstellar have used the concept of a wormhole, tunnels in curved space-time that connect two places, as a core tenet of travel to distant worlds. However, new research has come to spoil the party for science fiction fans by claiming that while wormholes exist and travel would be possible, they would be a waste of time. Presenting these findings, it's Harvard physicist Daniel Jafferis, along with Ping Gao at Stanford University's Aaron Wall. So they said rather than being a portal for fast travels, wormholes would be incredibly slow. So it says, Jafferis said, quote, "It takes longer to get through these wormholes than to go directly, so they are not very useful for space travel," end quote. However, rather than this research being for nothing, he believes that finding a way to construct a wormhole through which light could travel could help physicists in their efforts to create a theory of quantum gravity. He added, quote, "The real import of this work is in its relation to the black hole information problem and the connections between gravity and quantum mechanics." So let's skip ahead a little bit. So Jeffers said, quote, "From the outside perspective, travel through the wormhole is equivalent to quantum teleportation using entangled black holes," end quote. The latest theory is based on a setup first devised by Einstein and Rosen in 1935 that would later be known as a wormhole, or an Einstein-Rosen bridge. It's another thing it's called. But because the wormhole is traversable, Jeffers determined it may be possible to extract information. It gives a causal probe of regions that would otherwise have been a horizon, a window to the experience of an observer inside of space-time that's accessible from the outside. I don't know what any of that means. And then it goes on. There's a little bit left in the article, but it doesn't really explain why, if a wormhole exists, why that means that it would take longer to go through it. I haven't seen any, at least not in this article, I haven't seen any kind of explanation for that, so I don't really understand that. But it's just to show that there is not a consensus on wormholes, and apparently there is a model of wormholes that would actually take longer if you travel through the wormhole than if you were to just go there directly. So I don't know what to do with that, but I thought that it was worth mentioning just to show that there are other theories about wormholes out there.